Hello.
Hello!
Oh, yeah. Long time no see.
Oh, long time no see.
How have you been?
You ch- Oh, I'm doing great, but I'm at home right now.
Isn't your home with your daughter?
Yes. Yes, my daughter is here. Do you like to see her?
Yes, right. Can I see her?
Okay, wait for a while. She's here.
Oh, hi.
Say hi.
Yeah. Yeah, she's really cute.
Yeah. Yes. A lot of
Yes,
people are saying that
yes,
she looks
right.
like her dad.
Ah, yeah,
Because of her eyes.
yes. Mm, so cute.
Yes.
Yeah.
What? Mhm.
Yeah.
I've been waiting for you every weekend. You are not studying during the weekend?
Yes, right. Actually, Mint Academy's CEO doesn't allow us to join the Sparta event during the
Mhm.
coronavirus.
Mhm.
So I couldn't join the Sparta event. So I just add
Mhm.
one class today because today is a
Mhm.
holiday and then I have some time to have class.
Mhm. Yes. Because I've been teaching for like how many Saturdays and I never get to see your name. Where is T-Bong? That's why
Yeah.
I'm happy to see you. And I am wondering a while ago, who is Tay? This is your new account?
Who?
You. Mhm.
Ah,
Is it still the same? Mhm.
yes, right.
Mhm. Okay. So it's holiday. You don't
Yeah.
have any plans to do with your
Yeah.
family?
Yeah, actually, my wife and my kids went to visit my sister-in-law's house to spend the
Mhm.
holiday. But I have something to work to do even during the holiday, so I stayed at home.
Mhm.
Actually, I work. I did some report and then research at the Starbucks just
Mhm.
before.
Mhm.
In
Mhm.
Starbucks, lots of people will go there to study and then
Mhm.
spend time.
Oh. Okay. So even it's the holiday, you are still working just like me.
Yes, right, exactly.
Yes. Okay. So for our class, what do you like
Yeah,
us to do? Do you like us to have free talking, or you like to
mm,
use the senior
yeah,
article books?
yes. Actually, I have lots of articles to finish. So
Mhm.
today I'd like to discuss the number 1088, science and
Mhm.
technology.
Okay. Here, dancing stars.
Yes, right.
Proves
Okay. So
Einstein was right.
yeah.
Okay.
So may I read the article first?
Yes.
Okay. The star's orbit creates an ever-changing rosette shape predicted by Einstein's general relativity. Einstein's theory of general relativity has been proven right again, thanks to the wavelength dance of a high-speed star swirling around the monster black hole at the center of our galaxy. Astronomers with the European Southern Observatory (ESO) has been watching the star, named S2, orbit our local supermassive black hole for 27 years, taking precise measurements of the star's position and velocity as it swoops around the galactic center, roughly 26,000 light years from Earth. After watching the star completely nearly two full orbits, each complete orbit takes around 16 years. The researchers concluded that the star does not have a fixed ellip- elliptical orbit, as predicted by Isaac Newton's theory of gravity, but rather dances
Mhm.
around the black hole in a pattern that resembles a Rosetta drone using a spirograph. This sort of orbit, where the stars point of a crosset approaching moves swiftly around the black hole with each orbit, is known as Schwarzschild precision.
Mhm.
This one key sort of precision, or forward movement, was predicted by Einstein more than 100 years ago to describe the effect of an indefinitely similarly small object orbiting an extraordinarily massive one. The researchers wrote in their new study, published online in the journal Astronomy and Astrophysics.
Mhm.
Einstein's general relativity predicts that boundary orbits of one object around another are not closed, as in Newtonian gravity, but moves further in the plane of motion. Study co-author Reinhard Gengel, director of the Max Planck Institute for Extraterrestrial Physics in Germany, said in a statement, this famous effect, first seen in the orbit of the planet Mercury around the Sun, was the first evidence in favor of general relativity. 100 years later, we have now detected the same effect in the motion of a star orbiting the black hole at the center of the Milky Way. This is the first time that Schwarzschild precision has been confirmed in a star orbiting a black hole, the researchers wrote in their study. The team identified the deep roofs of ST after making more than 300 observations of the star using several instruments on the ESO's Very Large Telescope in Chile. Beyond adding one more log to the proverbial fire of Einstein's legacy, the new finding could also help researchers make more exact calculations of the types and quantities of matter located at the center of the galaxy. The researchers said because the S2 measurements follow general relativity so well, we can set stringent limits on how much invisible material, such as distributed dark matter or possible smaller black holes, is present. Study co-authors Gay Perry of the Paris Observatory and Karen Perrot of France University of Grenoble said in the statement, this is of great
Mhm.
interest for understanding the formation and evolution of supermassive black holes. That's all.
Okay, very good. I am interested about this. The title
Yeah,
is about dancing stars, right?
yes, right.
So,
Actually, it's very
um, I
interesting. Yeah,
mhm.
yeah,
Yeah. So Einstein is right. After 100 years, what he said is finally revealing its
yes, right.
image in the outer space, right?
Yeah,
So
actually, the
here,
interesting thing
mhm,
is the movement of the smallest one particles natural movement is
mhm,
exactly same with massive black holes movement. That's not
mhm,
yeah described by Isaac Newton, but only by it proved
mhm.
by Einstein. So it's a
Yeah.
I think Einstein is a really genius.
Mhm. You are right. I also believe that. And even after how many years? his theory and all of the things that he said is really happening. So I don't
Yeah,
know why did he predict all of that, right?
that's right. Okay.
Okay, so let's try answering the question, sir.
Yeah. Okay.
Number one. Mm-hmm.
Number one. What did the astronomers name the star which orbits our local supermassive black hole for 27 years? The
Okay.
astronaut called the star named S2.
Mm-hmm. Yes. So I am really curious why they use the name S2. Mm-hmm.
Actually,
Because
that's
if
not
Einstein just
described.
writes,
Yeah,
mm-hmm.
that's not described. Yeah, on
Yes,
the article.
it
Yeah,
doesn't describe anything, right?
yes,
How
right.
about number two, sir?
Number two, does the star have an elliptical orbit as predicted by Isaac Newton's theory of gravity? Actually, the star does not have a fixed elliptical orbit as predicted by Isaac Newton's theory of gravity, but rather dances
Mm-hmm.
around the black hole in a pattern that resembles a rosette drawn using a spirograph.
Oh, so that's why they call it a dancing star because of the it dances around the black hole.
Just right. For the Newton's theory of gravity, the movement
Uh-huh.
should be directly go to the center of the black hole. But as you can see
Mm-hmm.
on the image, the star just moves
Mm-hmm.
like swelling, yeah, dancing.
Yeah. Yeah, it's a spiraling movement, right? So
Yeah,
that's the star is moving. Wow, this is so amazing.
yeah,
And then number three.
yeah. Number three, what do you call the precision where the star's point of closest approach moves subtly around the black hole with each orbit? Mm,
Mm-hmm.
the this wonky sort of precision or
Mm-hmm.
forward movement was predicted by Einstein more than 100 years
Mm-hmm.
ago to describe the effect of indefinite, indefinitely small objects
Mm-hmm.
orbiting an extraordinarily massive one.
Mm-hmm.
Yeah.
Okay, yes, you are right. So here to describe the effects of an infinitesimally small object orbiting an extraordinarily massive one.
That's right.
Okay, and number four.
Number four, how many observations did the researchers do with the star? Actually,
Mm-hmm.
more than 300 observations of the star using several instruments on the ESO's Very Large Telescope in Chile.
Mm-hmm.
More than 300.
Okay, so they wow, that's really a lot of work. They were able to
Yeah,
observe it 300 different ways, right? So,
that's right.
sir,
Exactly.
let's proceed to the discussion question.
Yeah. Number one, in your own understanding, what is Einstein's general relativity? Actually,
Mm-hmm.
Einstein's general relativity is like uh, the time is very relative on your speed.
Mm-hmm.
So if you move fast, then the time go slowly.
Mm-hmm.
So
Okay.
the basic concept of the relativity, Einstein's general relativity, is the time is not equal to everyone or every object.
Yes.
So
Mm-hmm.
by the Einstein's
Okay.
general relativity, you can make some
Mm-hmm.
kind of a time machine and then go to the in the past or in the future.
you can travel, right? Time
Yes, right.
travel,
Yes,
because of
right,
the
exactly.
concept of general relativity.
Yeah,
Okay, number two. I'm interested to know about that, sir.
yeah. Number two, are you a big fan of Einstein? What do you know about him, and do you agree that he was a legend? Why? Yes, right. As I mentioned, I think he's a real genius, and then he he create lots of theory. Actually,
Mhm.
there was not proven at his age, but
Mhm.
actually most of his theory was proven as true after 100 years later. So that's why I
After,
can
yeah,
consider
that's
him a legend.
hmm if he's still alive until now, he could be one of the richest man in the world, right?
Yes,
A
right,
lot of
exactly.
people would like to consult him and would like to ask him, "What are you thinking right now?"
Yeah,
Right? I would also one of the people who will, who is already dying to meet him. Hmm.
yes, right.
Okay, sir. Let's proceed to number three.
Number three, are you fascinated by the stars and the whole universe? Why or why not? Of course, I'm fascinated by the star and the whole universe, and then I always wondering how human was created and what made human, and
Mhm.
then where we
Yeah.
go after we die.
Mhm.
Nobody know
Yeah,
at
that's
the
still a
moment.
question to me. Yeah,
Yeah,
I really want to know where people usually go after they die. Is
yeah,
heaven for real or is hell for real? I'm curious.
yes,
I
right.
hope Einstein also did some study about that, right?
Yeah, okay.
Okay, so last question, sir.
Yeah, number four. Do you think that there could be more predictions of Einstein that will be proven right in the future? Just by your answer. So,
Mhm.
I think we can make um, the time machine based on the
Mhm.
Einstein theory. So we may enjoy travel in the future.
Mhm. Yes, that's right. And
Yeah,
then this one, I also agree with this one, sir, because I think more of his predictions will really happen in the
yeah,
future
yeah.
because more than 10 already, or based on his studies and observations, scientists can really use it as their foundation, right?
Just right, exactly.
Mm-hmm.
Okay, time is almost
Yes.
up. Yeah,
Okay. Yes,
and
sir.
yeah, I
Time
hope to
is
see you
up,
again
and
soon. Yeah,
yes, sir. Thank you for dropping by. I'm happy to
yeah.
see you too. See you. Bye
Okay,
bye.
bye bye. Bye bye. Thank you.
Bye, sir. Thank
Bye.
you.